Yeah, cam's on everyone. So let's start off. Great. We'll be leaving little early today. I'm not keeping that well, so maybe I won't give you a break. So I might wrap up little early. So let's go ahead. Hope everyone has gone through the notes. Let's go ahead with one more question. Like I said last time, we were doing distances and displacements, and these were the two formulas, if you remember. So distance is mod v bar dt, that is speed into time, or distance is 1 plus dy by dx whole square per root. I hope you guys remember this. You don't remember this, you can note it down. So we will need this. So yeah, we use the time thing if time is given, and we use this y and x. Y and x if the y and x are given. Let's see. So particle is moving along the curve. Y is equal to root over 4 minus x square. From root 3 comma 1 to 2 comma 0. Find the distance traveled. So in this thing, I gave you the path equation. Let's get this. So the path is given and you're expected to find the distance. Last time, if you see, I gave you a position vector and I asked you for distance. Yeah. So how do we do this? I'll show you the equation there. See, you have to use this. Distance is integral root over 1 plus dy by dx ka whole square into dx. So first differentiate this, do dy by dx, take that and substitute here, and then integrate. That's the process. So you know why differentiate it, chain rule, take that, put it in this, and then you are getting in terms of x. So you have to put x ka limits. So x is going from root 3 to 2. Bring everything in terms of x or everything in terms of y. I think getting everything in x is a better option. So Hmm, let's see. So what is dy by dx? dy dx of 4 minus x square whole power half. That looks right, Ahan. So this will be half into 4 minus x square minus half, and then differentiate whatever is inside. That would be minus 2x. That will be minus x by root over 4 minus x square. Take this and substitute here. 1 plus x square by 4 minus x square dx. That would be root over 4 by 4 minus x square dx. That will be distance integral dx by root over 4 minus x square dx. So everything is in terms of x. So limits are going from root 3 to 2. You are going from root 3 to 2. And this integration is looking like what? This integration is looking like this one, isn't it? Dx by root over a square minus x square. Integration substitution, the second part. So I will show it anyways, but refer page 160, calculus. So how do we do this? Integration by substitution. Put x is equal to 2 sine theta. Dx will be 2 cos theta d theta. Substitute there. 2 times dx will be 2 cos theta d theta. Denominator will become 4 into 1 minus sine square theta. 2 cos theta d theta by that is also 2 cos theta. 2 times integral d theta. So that's 2 times theta. Limits are root 3 to 2. But what is theta? Theta is x by 2. Theta is sine inverse x by. So we have 2 sine inverse x by 2 limits root 3 to 2. There is actually, you can get the limits also here only, but yeah, let's not confuse you. And simplify that 2 times when we substitute the limits. Substitute 2 there, it will be sine inverse 1. Substitute root 3 there, root over sine inverse root 3 by 2. What is sine inverse 1? When do you get sine 1? Matlab, when theta is 90 degrees. That is pi by 2. Remember to write them in pi. What is root 3 by 2? 60 degrees. That is pi by 3. That would be pi by 3 meters. Are you clear with those steps? You're getting the meaning of limits? What is sine inverse 1? Sine 90 is 1. So sine inverse will give you the angles. Please have a look at the steps. This is integration by substitution. This is the second one that we did. Any doubts on the steps here? All clear how we handle this? Now, if you actually try to see what is this path that we got, this y is equal to root over 4 minus x square. If you square it on both sides, we get x square plus y square is equal to 4. This is an equation of a circle. Right? And this would be 2 square. So basically, in case you don't know, don't worry about it. Max will teach you, but in case you know, that is fine. So basically, this is the equation of a circle whose center is at origin, and the radius is 2. This is the general equation, everyone. X minus h whole square plus y minus k whole square is equal to r square. This is a general equation of a circle. H comma k is the center of a circle. R is the radius. This particle was going on a circle, and it is going from root 3 comma 1 to 2 comma 0. So 2 comma 0 was this point. Root 3 comma 1 was this point. And from here to here, you can clearly see this angle was 30 degrees. What did I ask you indirectly was the arc length, isn't it? This thing was r into theta. R was 2 and theta was pi by 6. That was your pi by 3. Is that making sense? Geometrically, how it is looking? Yeah, but every time you won't be so lucky to get a equation. Like, what if they give you something weird and you don't know the equation? Clear how we handle this? So this guy was actually going on a circle of radius 2 and it covers an angle of 30 degrees. That's why we are getting r theta, which is pi by 3, which we did all this thing there. So, any doubts on this? Clear, na? Shrikant, Yukti? Clear? Yukti, clear? Radhika? Anish?
Sir, how do you know that the whole curve is a part of circle?
Like I said, na, this thing is an equation of a circle that you won't know right now. Max will teach you. But for now, know this much. Like, this is an equation of a circle. It's more of a max based. So yeah, it's you won't realize it right now. Like until unless you know this or seen this before, you won't have realized it. Right? But don't worry. Max may have a full chapter on this. They'll teach you for a month. Just to give you a rough idea, you should roughly have an idea. हाँ, ये circle का equation है, ये parabola equation. So I'm showing it right now. So next time when it comes, you know. Great. Next thing. So we got a wheel. This is a wheel of radius r. There is a point A at the bottom of the wheel. So consider your cyclic a wheel, okay? And let's say you tie a ribbon to the one of the spokes. And the cycle starts going forward. If you observe this, you will notice this point, right, will actually start going in some curve. So A actually something like this. I didn't draw it well, but yeah, A would come something like this. So A would travel something of this sort. So when the wheel rotates by an angle theta, the point A will go something like this. So let me show you the path. Hmm. Are you guys able to see this? Okay, I'll make it big. There, see. This is how the point A will go. So the point on a wheel, right, when you're moving forward, it actually goes like this. This is not a semicircle. It looks like that. And these are called cycloids. You need not know that. I'm just telling you. This is called a cycloid. This is not a semicircle. So when you take a wheel and you roll it on a floor, this point is actually jumping like a frog, isn't it? It looks like a semicircle. It is not. And if you remember in basic maths, I taught you this also. The horizontal distance traveled here is 2 pi r. So whenever a wheel rotates by one revolution, it will travel a distance of 2 pi r. That I think I showed you somewhere here. I showed you in vectors. We did this something like this there. Look at this thing here. If I take a circle and if I mark it with four colors, red, green, black, and some sky blue, and if I roll this on the floor, look at the colors on the floor. You will get red first, then green, then black, and that sky blue thing. That means whenever the wheel rotates one revolution, it will travel the distance of 2 pi r, isn't it? Actually, this is how your vehicle knows with what speed you are going. Ever thought about it? When you're giving an accelerator, how does your scooty know with what speed you're traveling? If you ever have an Activa, right? Observe karke dekho. For the front wheel, there will be two wires. One wire is the brake wire, and one is the sensor ka wire for the speedometer. So there's a small sensor there which counts the number of revolutions your wheel is doing, and it multiplies the number of revolutions into 2 pi r, and that's how it measures what is the distance traveled. Did you ever see this thing? ये marathons होते हैं ना 42 kilometer, 21 kilometer. Did you ever see like how do they measure the path of that entire track? No one takes a scale and measures it. They have a small wheel kind of thing. You sit on that and you just keep pushing the wheel. It will count the number of revolutions and multiplies into 2 pi r, and that will give you the distance. So this is how your car knows with what speed you're traveling. How does the car know with what speed you're traveling? Right? So this is page 73. We did have a discussion on this. So whenever a wheel completes one revolution, it will travel 2 pi r. So our question, find the distance traveled by this point A when the wheel rotates by an angle theta. So A is a point on the circumference. Initially, it is at the bottommost point. Find distance traveled by A when the wheel rotates by theta. Now, for simplicity, right? Always assume angle theta is acute. You don't worry whether it is obtuse, 90 degree. For convenience, always choose theta is acute. The angles will take care of themselves. Always, whenever they say variable, assume it is positive. Whenever they say angle, assume it is acute. Always, you can assume positive stuff. Keep your life simple. The variables will take care of themselves. Let's see how will you do this thing. This would be a good question. And then they can ask you, like, find the distance traveled in one revolution. So be careful. Displacement and distance are two different things. What is the distance here? Distance would be the length of this red line. What is the displacement here? This horizontal one, which is 2 pi r. So people think that 2 pi r is the distance traveled. No, that is the distance traveled with the center of the wheel. So I'm asking you the cycloid ka path. And cycloids are special, huh? Meaning just an interesting thing. If you want to send something from point A to point B, and let's say you design different tracks. Let's say you design a straight track, right? Or you design a circular track, or you design a vertical and then horizontal track, or if you design a cycloid track. And when you leave the ball in all these four tracks, the cycloid will reach the B in the shortest time. So between 2 points, a cycloid will always give you the least time. So that is one of the properties of a cycloid, and it's pretty interesting. When think about this, let's say tomorrow you're loading cargo into a ship, and you're sending cargo here, and don't you want the ship to get filled up faster? So designing that thing like a cycloid will actually save you time. So that's one of the property of a cycloid, and just an interesting thing. Yeah, let's get this thing. How will we do this? Now, when you give me a question like this, what I start thinking? I said, okay, first of all, what the hell is this? Fine. So you curse the problem for a 10-15 seconds. And then let's get back to solving. And then you think, okay, distance, how many formulas do I know? I know only two formulas which were taught. Distance is integral mod v dt. Second was dx root 1 or whatever is this thing. So this thing, if I want to use, I need to know the time and the speed. This thing, I need to know x and y coordinates. So looking at this question, I don't think I know anything in time. But if I take the initial point as origin, can I find the x and y coordinate of point A? Can we find that? We can find that. Why? Because we already did that. If you remember in this question, vectors, that was the whole question there. If the wheel is rotating, find the position vector of OA bar. So we already found the coordinates. This is your x coordinate and this was your y coordinate. So we actually did this in vectors. So then what? So you got x coordinate and y coordinate. Can you try again? Get your x and y on coordinates on your own. I'll give you a minute or two, and then I'll see. So once I know my x and y coordinate, then I think I can put it in the distance ka formula and integrate it. So see, that is how it is. You will never know whether you'll get the answer or not. It is always a surprise till the end. You just keep thinking, okay, this thing might work, so let me try. And you keep trying, you fail sometimes, and sometimes it clicks. And as you keep doing this repeatedly multiple times, at some point your brain will start becoming better at it. Yeah, you'll never be perfect. Maybe out of 10 times, you'll be right 8 times, and that's good. You have to keep failing, right, and get used to it, so the brain will learn. It's important. So people tell me, like, you should not trust everyone. Yeah, but then, if you don't trust anyone, then you'll never meet the right people. At least that's what I have seen. If you meet 10 people, and the 9 people will be fraud. Be careful, right? Give them little, what do you call it? You should trust them a bit to see whether how much good they are and all. And in that, you'll find one good person. And if you meet like 100 people, you'll find 4 or 5 good people. And that many people are sufficient for life. So you need to fail a bit. My school friends are hopeless people. Easy to figure out. I think Ahana got something. Yeah. Ahana got it. So Ahana, if it goes for a full revolution, what will be the distance traveled? Did you guys get the x and y coordinates? So let me just take it from there. Okay. I'm not going to write it again. So this is how you do. When the wheel rotates by angle theta, the center of the wheel will travel at theta r theta. That makes sense. Why? Because for one full revolution, you will travel 2 pi r. If you cover only theta, then you travel r theta. Clear? And then we got the coordinates from here. So if this is the triangle r and theta, this is r cos theta, r sin theta. So from there, we found my x and y coordinate. So this is your x coordinate, r into theta minus sin theta. Y is equal to r into 1 minus cos theta. Great. Now what? There, I give you x and y coordinates. So what was the distance formula? In case you don't remember again, integral root over 1 plus dy by dx whole square dx. And what was x? X was r into theta minus sine theta. Now the problem here is, how do I get dy by dx from here? You can't. So what I do, I'll do dx by d theta. That would be r, this would be 1 minus cos theta. And what is y? R into 1 minus cos theta. I'll do dy by d theta. That would be r 0, cos ka differential is minus sine theta. That will be plus sine theta. Now I will divide them. Dy by d theta by dx by d theta. This would turn out to be dy by dx, which comes out to be 1 minus cos theta by sine theta. Yeah, right, Anna. Are you clear with this? Now, if you show this to a math teacher, he will punch you right and left. But physics mein chalta hai. It works out. You get the same result, so we'll not worry about it. There, we got dy by dx. And then we got dx also from here. Substitute everything here. So root over 1 plus dy by dx whole square is 1 minus cos theta by sine theta ka whole square. Yeah, it looks a little big and all, but let's see. And what is dx? Remember, dx is this guy. R into d theta 1 minus cos theta. Perfect. Limits will go from 0 to theta. See, I brought everything in terms of theta. Is that making sense? Yeah, no, let's just expand this. Yeah, it might look bad, but it is not. You will get a pretty good one. Integral root over, bring it this side, sine square theta. Expand that. I think I wrote reverse, na? dy by dx. Yeah. Sine theta by 1 minus cos theta. Hmm. Expand this. 1 plus 2 cos theta plus cos square theta plus sine square theta by 1 minus cos theta ka whole square is equal to r into 1 minus cos theta into d theta. Cos square theta plus sine square theta becomes 1. So that will be a root over 2 minus 2 cos theta. The denominator in this thing gets cancelled. This guy and this guy gets cancelled. One r comes out and we are left with d theta. Any doubts still here? It's little lengthy. And then you have to just integrate that. So distance will be r into integral root 2 root over 1 minus cos theta d theta 0 to theta. Now there is no direct way to integrate this, but we know something. 1 minus cos 2 theta is 2 cos square theta. याद है? This comes from your basic maths. I told you this will keep coming multiple times. 1 minus cos 2 theta is 2 sine square theta. I'm sorry, I wrote wrong. That's page 15. Basic maths. You will keep going back. So don't think like, the chapters will just keep going forward. You need to keep referring. Now, theta ka place mein what you have? So replace theta with theta by 2. When you do that, 1 minus cos 2 theta becomes 1 minus cos theta. 2 sine square theta becomes 2 sine square theta by 2. Take this, substitute here. You can see, right, how much mathematical operations are going on. Integral, that would be root 2. Sine theta will come out. Root 2, that will be 2r. And what is sine ka integral? Minus 2 cos theta by 2. Limits 0 to theta. That would be 4r. 1 minus cos theta by 2. Again, what is 1 minus cos theta by 2? If I do the same thing here, replace theta with, again, theta by 2. This will become 1 minus cos theta by 2. It's 2 sine square theta by 4. Take this and substitute here. You end up with 8r sine square theta by 4. That's your distance. This is a tough one. Even for your seniors, they do struggle a bit, but there. That's a pretty good result to remember. For one full revolution, the distance would be how much? 8r. So this distance will be 8r. This would be your displacement, which is 2 pi r. Remember that result, 8r? They have asked that question in bits and CET and those kind of exams. They won't expect you to integrate all this. They'll expect you to know the result for full distance to 8r. Again, let's see what we did. The whole thing I'll explain you. First thing, we found the coordinates. I hope this page was clear. Right? When the wheel goes theta, the center will travel r theta. Once we got the coordinates, I got x and y. I did dx and dy. I substituted in the formula. It's all math from here. At this point, physics got over. This is all maths. There's no physics here at this point. Once you wrote this formula and you differentiated this, physics got over here. Then it is just a matter of simplifying and using this 1 minus cos 2 theta 2 times. So full revolution, theta is 2 pi. Distance will be 8r. Got this? So if you have a wheel of radius r, the thing will go 8r. This is a very good result. Later on, we will see this thing. It comes in some really good chapter. Magnetism, that comes in 12th. I'll show you how it would look. So there was a question like this. Don't worry about it. So there is a particle, there's electric field, there's a magnetic field, blah, 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 everything. When you solve this problem, right, the answer you get, end of the day, will look like this only. So we do such kind of thing. That's what I'm saying. I'm going to relate this to something else in the future. So if you don't know how to do this, then you'll get stuck in that chapter. No one will ask you this question in the exam. That is what I keep saying. Advanced may questions don't repeat, but patterns repeat. They might not ask you the exact same thing, but at least in the paper, right? Even in this year paper, there are at least 50 to 60% of the questions were similar or something very close to what we did in the notes. And not because I am guessing or something. It happens with anyone. You take anyone notes, whoever is teaching you. By the time I finish your portion, I'll teach you around 1400 questions. When we do 1400 questions of this level, don't you think something will similar will look somewhere? That's it. It is just a matter of probability. It is not like anyone is guessing. And see, the advanced paper also, right? Understand one thing. The examiner does not know that you are preparing for advance, you are doing all tough questions. The examiner का main motto क्या है? There are kids who are in rural areas who are studying in Kendra Vidyalaya and all. Those who don't have access to proper coaching, those who can't practice high level problems. These people have studied only NCERT and they're trying to give an advanced exam. Isn't it unfair to give a whole paper something really weird? So the examiner will make sure at least there are 50 to 60% of the paper. If the kid has smart enough, he can think, and if he has done NCERT thoroughly, he can handle at least 50% of the paper. If you have done your last 10, 15 years PYQs, you have done all this 50% paper, the kid should be able to handle. So that much leeway you will have. So you should be thorough with your stuff. Anyway, so that is one more thing. Any doubts on this? Again, you really want to learn this, you should take a paper and derive the whole thing on your own today or tomorrow. No matter how many times you go through these notes, it will feel like, हाँ मुझे कुछ समझ में आया, but it was looking weird.
Sir, can you explain the third step here?
Hello.
Yes, sir. Yes, sir. I can't hear you.
Yeah, can you hear me now? Which one? This step?
Yes, sir.
वो साइन का इंटीग्रल है ना. What is sin ax का इंटीग्रल? 1 by a cos ax, right? a का प्लेस में you have half, so ऊपर चला जाएगा ना, you get a 2 in the numerator.
Yes, sir. But then how does the root 2 become 2?
Because there's one more root 2 sitting outside.
Oh, so we can just multiply it like that.
Why can't you multiply 2 root 2's? You don't like roots?
Sir, I thought because it's in the brackets, you can't or something.
Why can't you? If you have a constant into a function, won't the constant come out of the integral?
Yes, sir.
Comes out, na? So there. Clear with that?
Yes, sir.
Yeah. I thought you hate roots, so it's okay. And it is fine. So we call them like a racist, right? We call them rootist. People who hate roots. Let's see one more. That's a bad joke, I know, but let's see. That's a good one. Let's do a little more. What is average speed and average velocity? Let's define that. So, what is average speed? Average speed is simply total distance by time. That would be integral. What is the total distance? Mod v dt by integral dt. This is a mathematical way of writing. Yeah, but what it means is simply distance by time. What is average velocity? Average velocity is your displacement by time. Which is integral v bar dt by integral dt. Yeah, that is just a mathematical form, but simply we can say like this. So we can also write this average velocity is simply delta r bar by delta t. Right? And what is delta r bar? That is r final minus r initial bar. So average velocity ka direction is the same as the displacement vector. Average velocity and the displacement vector are parallel. Or you can say average velocity is along displacement. And now what we do, right? So the mathematical operation again. See again, what is average velocity? Displacement by time. What if you make the time very small? If delta t becomes very, very small, then your average velocity becomes instantaneous velocity. And this is how actually we got the whole differentiation from. If you make the time very, very small, then you start getting speed at every instant. Then your velocity v becomes limit delta t tends to 0, delta r by delta t. Remember this, what we call this? Since we are lazy to write that limit, we write this thing as simply dr by dt. Yaad hai? Differentiation. If you remember, that's how we started that whole differentiation ka story. Like we said, if you take a 2 points on a curve, it becomes a slope. So the slope delta y by delta x doesn't make sense. But when you make delta x tends to 0, it becomes dy by dx. So average velocity becomes instantaneous velocity when the time interval is very small. And what is the direction for instantaneous velocity? Instantaneous velocity is along the tangent. So it's always along the tangent. So just to give an example, think of like this. Let's say if a particle is going in some weird path like this, this is the initial point. Let's say the particle has reached here, B. If I ask you what is the average velocity, see, understand the meaning of average velocity. Average velocity assumes you have gone directly from A to B, isn't it? Displacement by time. So if you just draw a line from here to here, this is your average velocity from A to B. What is the instantaneous velocity? At point B, this particle is going this way. That's your instantaneous velocity. Suppose you're going from, let's say, A to C. This is your average. What is instantaneous? Along the path. So this is your V instantaneous. So if someone asks you find the average velocity ka direction, just join the initial point, final point, draw a line. That's your average velocity ka vector. What is instantaneous velocity? It's always tangential. So V instantaneous will be like this. It's going always along the path. Is everyone clear with the directions? Okay, so depending on the point, the average velocity will keep changing. The instantaneous velocity also will keep changing. Any doubts on this? All clear with the directions? So let's see a question on directions before going ahead. Let's say we have a particle, x coordinate and y coordinate. Just draw the path maybe. So let's say it is going something like this. This particle is going from A to B. It's going along this curve. Good question. How many times does V average and V instantaneous become parallel? Again, just to give an idea. For example, if I take this point, this is the V average, this is V, are they parallel? No, right? Suppose if I take this point, V average, V, are they parallel? No. V instantaneous, V average, they're parallel, so they're not parallel. So if you keep doing this, at some points they'll become parallel. How many points does that happen? Be careful, I'm not asking you maximum minimum. Don't get confused with that. Just to give a little more context if you want. So see, average देखो कैसा होगा, ये V average था, ये V average, V average, V average. So you just keep joining all the points from here. These are all V averages. And I'm saying there are some points where the instantaneous and the average become parallel. How many times does it occur when you go from A to B? I hope the question was clear. Someone is not clear with the question, please ask. This is the path of a particle. You're going in this random amoeba curve. When you go from A to B, how many times your average velocity and the instantaneous velocity become parallel? Okay, people are saying 6. Think, I'll give another 30 seconds and I'll show you. Okay, let me show you. So what is V average? You have to just draw a line from initial to final. What is V instantaneous? Whenever it is, it's always tangential to the path. So look at this. Whenever the line, see from A, if you draw different lines, when this line becomes a tangent to the curve, isn't that the point where the instant is also tangential? Look at this point here. At this point, this is your V average. And at this point, your V tangential, V instantaneous also is this way. I'll just call it V instantaneous. So that is one point. Making sense? When the V average becomes a tangent to the curve, if it becomes a tangent, that is a direction, right? And we need to find that. So V bar is always tangential to the curve. So you just need to find the points where V average also becomes tangential. So for V average to be parallel, the line joining initial and the final must be a tangent to the curve. Great. Now, with that logic, what do you guys think about this? If I take this point here, do you think this is a tangent? No, right? That's what it said. There is no maximum minima here. I'll take some more point here again. See, so when it goes something like this, it will graze somewhere here. It's not a maximum minimum point. So यहाँ पे एक tangent था. When you go somewhere here again, you will graze somewhere again here. यहाँ पे एक tangent आएगा. When you go again like this, see, you can cross the point. It should be tangential somewhere. So it will graze somewhere here. It will be one tangent. And once you go somewhere like this, you will graze again here. This will be a tangent. So this is one point here. 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 So that's like 1, 2, 3, 4, 5. 5 is the answer. At time dx, we'll cut once more. What do you mean by dx?
Sir, add the initial point.
Initially, you won't count it. See, zero vectors have undefined direction, so we don't count it.
Okay, sir.
Yeah, I mean, if you count that, agreed, but technically we don't count it because when you're starting initially, your displacement is zero. A zero vector someone is starting from here, you go like this, and then you go like this. Now tell me how many times they'll be parallel. I just made up something random. How many times the average and the instantaneous are parallel? Yeah. You got the idea how to do this. Mm, okay. Dave and Anish got something. Same. What about others? Anyone else? We have 2 10s and 1 9. Okay, let's see. So from here we will draw a tangent. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, maybe if I draw somewhere here, it might graze again somewhere here. I think that last part I didn't draw it well. So yeah, you could have counted it as 9 or 10. So I'll do one thing. I don't want that last part. So I'll just draw it like this. So yeah, if you don't count that, it is 9. Then you guys are right. The people who said 10, I think you counted that. Then you are also right. My bad. I didn't draw it properly. But everyone got it how to do this?
So do we not count the first part where it's going up?
See, again, I'm saying you're counting maxima minima. So if you take this point here, can you draw a tangent like this?
No, sir, not there, like little bit before that.
Here?
Yes, sir.
Like this, you're saying?
Yes, sir.
And that is just because I didn't draw it properly, right? It's like you're going like this, so you can't cross. I know the way I drew it, it was a little weird, but think of like this. So you can't cross. How will you cross? Think of it like a sine curve. So from here, you can't draw a tangent to yourself, isn't it? Or maybe
Oh,
you're asking for the starting point, yeah?
sir, I was asking for like little bit on the
I know the way I drew it. I think I did it like this, na. So you thought you can draw like this. Yeah,
yes, sir.
like I said, I just drew it randomly. But okay, if it was like that, what you said was right. All clear with this? Let's see one more. Let's say we have a clock, 12 o'clock, and yeah, you know the numbers 1, 2, 3, 4, 5. So we have a hours hand and we have a minutes hand. Which is 1 meter, pretty long thing, right? So A is the tip of the hour's hand. We don't care about the minutes hand, so let's ignore that. We can maybe take that also. Why to ignore it? Poor thing. So OB is your minutes hand. Yeah, we can play with that also, which is let's say 2 meters. Find average velocity of A average speed of B when time is 6:40 p.m. Let's get this. Just to give a little more context, how will A and B travel? A will go in a circle. B is also going in a circle. You know your regular clock. Initially, time is 12 midnight. Now the time is 6:40 p.m. So this point A and point B are going in circles, 1 meter and 2 meter. Find the average velocity of A and average speed of B when the time is 6. So we have a clock here, 1 meter and 2 meter, A and B points. So you can see A and B simply go in circles. So find the average velocity of A and average speed of B when the time is 6:40 p.m. Question is clear? I'm sure you must have seen a clock multiple times. So just get me the numbers and leave it, okay? Don't worry about if you got something like sine 70 degrees, you can leave like that. Don't need to simplify. Just get me the main things and just leave it like that. You're not a max class. I know you can handle those numbers later on. I just want to see whether there is a trap. Did you get the trap or did you understood how to draw the picture? That's what I'm more concerned about. Let's give it a try. Okay, let's see. Did you guys draw the clock first of all? If you have a clock in your room, just look at the clock right now. It's 9:30. So is the hour hand exactly at 9? Is the hour hand exactly at 9? No, right? So how does 6:40 look like? So this is 6, 7. This was 8, right? So 6:40, right? Think of like this. The hour's hand will be here. The minute's hand will be here. That is your OB. If it was exactly 6, then you would have been here. But 6:40, right? You would be somewhere here. Like this, isn't it? Think of like this. In 60 minutes, the hour's hand, you can say OA vector, right, goes from one digit to another digit or rotates 30 degrees. Do you guys agree with that? 30 degrees how? Because every time you do 60 minutes, you go from one number to another number, and there are 12 numbers and 360 degrees, right? So the angle between any two digits consecutive digits is 360 degrees by 12. Now you tell me from unitary method, then in 40 minutes, how much will it travel? In 40 minutes, OA rotates 20 degrees. That means this angle here is 20 degrees. Is that clear, everyone? That is how OA will look like. Or, most people think like this. 6:40, it will be here. When it is 7 o'clock, will the hours and suddenly go to 7? No, right? It is also
Sir, what is the length of OB given?
one second. OB, right? OB was 2 meters. OA was 1 meter. Everyone clear with the picture? What was the second trap? The time was 6:40 p.m. Meaning, how much did this thing actually rotate? The hour's hand has completed already one revolution, isn't it? Night 12 to afternoon 12, afternoon 12 to evening 6. Are you getting this? So the time is 18 hours and 40 minutes. It's not 6 hours 40 minutes. It's 6:40 p.m. Total time was 18 hours and 40 minutes. So yeah, you have to be careful with that. Yeah, I think we are done. So now we just have to calculate the numbers there. So if you look at Eka motion, this is how it looks. So A must have completed one circle, right? This was 12 a.m. to 12 p.m. So you have completed one circle. What am I asking you? Average velocity. Okay, average velocity, so we don't care about this. So you just need displacement. Initially you're here. This was A. Now you're here. So this distance is displacement. Because I don't care how you traveled. We need only initial and final. So basically you got a triangle. This is 1 meter. This is 1 meter. And that angle is 20 degrees. So that's 160. This angle is 160 degrees. So meaning if you make this 80 degrees and 80 degrees, it forms a isosceles triangle. This length will be 1 sine 80. This length will be 1 sine 80. Therefore, average velocity of A will be 2 times sine 80. That's the total displacement of point A. And by total time is 18 hours. That is 18 into 3600 seconds plus 40 into 60. So that's the total time. You can leave it like this. No need to simplify. Clear with this? Instead of sine 80, you could have got cos 10 also. Both are right. Sine 80 is also equal to cos 10. So if you got in terms of cos, you're not wrong. Is this clear, everyone? So that's the main two things, like, the hours hand will not be at 6 and the time is 18 hours 40 minutes. What is the next thing? We are talking about Bika speed. Okay. So how much did B travel? B traveled 18 revolutions, 18 plus 2/3 of a revolution. That thing just kept on going. Every 1 hour you completed a revolution. So the distance traveled will be 18 plus 2 by 3 into 2 pi r, which is 2 meters. So average speed is 18 plus 2 by 3, 2 pi 2, and the time is 18 hours. 1 hour is 3600 seconds plus 40 into 60 seconds. Yeah, you can leave it here. No need to simplify. Got this? There. So that's a straightforward thing, average speed and average velocity. Clear with this? Yeah. There again, if you see, not really a tough question, but something which you see every day. Any confusion? Anyone not convinced with anything, please ask. Clear? Let's do something a little more easy. This is a standard question. When I say standard question, these are the kind of questions you'll get in mains, bits, CET. They do repeat. So those are standard questions. So let's say we have a vehicle which is going with speed V1. A vehicle goes in a straight line. So it's going with V1 and then it goes with V2. Case 1, vehicle goes with speed V1 for time T1 and speed V2 for time T2. That is your first case or first question, you can say. Case 2, vehicle goes with speed V1 for half the distance speed V2 for remaining half. Find the average speed. What is the average speed? Total distance by time. They have not given distance or anything. So let's get this. This is a standard model. Clear, everyone? They didn't give you the distance. Nothing is mentioned. So answer comes in terms of V1, V2, T1, T2. Seriously, no one got an answer. Shreya got that thing right. Get the second one also. Right, Sumana. Got both others. You guys were just, it's too, I thought so. And it was too long to type, so you're not typing. Yeah, that was right. Right, Karthik. Right, Srikanth. Okay, let's see the first one. See, go to the first one. Just draw a small picture. You will see you're traveling with V1 for time T1, then you're traveling V2 for time T2. Great. So initially, how much distance will you cover? You'll cover V1 T1, then you'll cover how much? V2, T2. So simple thing. So what is the average speed? Total distance by total time. How much did you travel? You traveled V1, T1. Then you traveled V2, T2. And the time was T1 plus T2. Easy. The second thing, you're saying you're traveling with speed V1 for half the distance and V2 for the remaining half. Now, what is that distance? I don't know. So let me call it as S by 2 and S by 2. So for a distance of S by 2, how much time will you travel? Distance by speed, S by 2 V1. What is the time here? S by 2 V2. Remember, S I don't know, you have to eliminate it. So what is the average speed? Total distance by time. What is the total distance? S. What is the total time? T1 plus T2. Substitute here. That would be S by 2 V1 plus S by 2 V2. That turns out to be 2 V1 V2 by V1 plus V2. Got this? So I assume the distance is S, and it is given in the question you traveled half with V1 and the remaining half with V2. So from there I got time in terms of S and V and substituted it. All clear with this? Easy stuff. This is what I'm saying. You get questions like this in bits and CET. You won't have time. Like you should see the question, you should know what to do. So this is a standard model. So if I do a little modification here, give me a try about this. So we have a vehicle going with V1, and vehicle goes with V2, and vehicle goes with V3. So a vehicle goes with speed V1 for half the time, half the total time. How much is the total time? I don't know. V2 for half of the remaining distance after traveling T1, whatever is the distance is left, uska half distance you traveled with V2 and V3 for the remaining distance. There, I mixed up time and distance in one question. And average speed. What is the total distance? I don't know. What is the total time? I don't know. So initially you traveled with half of the time with V1. And then जो भी distance बच गया, in that half distance you went with V2 and the remaining half went with V2, V3. Find the average speed. This would be a decent one. The previous two would be like standard CET level questions, like they have come multiple times. So फिर भी means में this is still a decent question. Try. I'll give you 2 minutes. It is just big and lengthy. Like you just draw a picture carefully and try to get the variables. You will see. Now, in case you got it, you just said done. No need to type. And once you get the answer, you can verify. Okay. One done. Anyone else? Okay, let me show you the picture. Hana also done. Okay. Okay, let's see. Now we don't know the total time. So let the total time be t. So you are traveling with v1, right? And let the time be t2. T is total time. So then you started going with v2 and then you started going with v3. So from here to here, your distance will be v1 t by 2. Great. Now whatever is the remaining distance left, let's call this thing s and let's call this thing s. What is this time here? Let's call it t2 is s by v2. You take any variables you want, and this t3 will be s by v3. Perfect. But I also know t2 plus t3 is t by 2. Agreed? Because you said half of the time you traveled with t by 2. Matlab the remaining time, whatever was that, was t by 2. If I substitute here, that will give me s by v2 plus s by v3 is t by 2. So from here, I'll get s ka value, which is t by 2, 1 by v2 plus 1 by v3. Got the data? Great. So what is the average speed? Total distance by time. What is the total distance? v1 t by 2, that is s plus s, which I don't know what it is, and by t. But what is this? I just now calculated it, dump it here. That would be v1 t by 2 plus 2 times s, which is t by 2, 1 by v2 plus 1 by v3 by t. I'll just take it to the next page. Right? The 2 will cancel, tt will cancel. Just check with the variables and b1 by 2 plus 1 by, that would come out to be v2 v3 by v2 plus v3. Yeah, cross multiply. v1 v2 plus v1 v3 plus 2 v2 v3 by 2 times v2 plus v3. Did you guys get the same thing? You have to assume variables. So we will say let the time be t, and then we'll say let the remaining distance be s and s. Like, okay, you want s by 2, s by 2, take anything you want. We have to eliminate it. So the total distance traveled will be v1 t by 2 plus s, and you said total time was t. So you have to get everything in terms of t and eliminate s, and then you're done. I think the main trick was to realize t2 plus t3 is t by 2, because the question you said first half of the time is v1. That means remaining time was remaining t by 2. Is this clear, everyone? Got this? Not too tough, but yeah, equations and stuff. You just have to be careful with this. Clear with this? There. So, like I said, I'm not keeping well. So with that, we'll wrap up for the day. Next class, when we catch up, we will continue from here. There is one more important model there, which we'll see in the next class. And then mostly we will start off with uniformly accelerated motion in the next class. That will be also good. So, okay, with that, we'll wrap up for the day. Right. And remember, there's a test online till Friday. Everyone make sure to give it. And we'll catch up on next Monday. We'll continue from here. So, any doubts, anything else, please stay back and ask. Or else you're free to leave. I'll see you guys again next Monday. So, take care, stay safe.
Thank you, sir.
Yeah,
Thank you, sir.
bye, Ray.
Thank you, sir.
Yeah, bye, Ray. Take care. Any doubts in the class notes?
So,
Sure, I had it out in the last week's notes.
There is no last week note. This is the notes, right? Which one?
Oh, मतलब last classes notes.
बोलो page number क्या है?
Sir, 1 second, I'm finding it.
Yukti, bolo na. What happened?
The test on Friday, what is the syllabus?
Syllabus was vectors and calculus. You don't have the syllabus, na? Do one thing, WhatsApp में मुझे class के बाद ping करो. I'll give you the testing platform का website thing. You can register. I'll give you access for the test. I'll also send you all the class notes you have done. I'll send you all the material and stuff.
Okay.
You
So,
have my number, right?
Hmm.
WhatsApp में मिल जाएगा group में.
ठीक है.
Right? You see there? Just ping me
Yeah.
there. और नहीं तो लिख लो if you want. 983328. So just say hi in WhatsApp. I'll send you all the details. You can register. I'll give you the notes and जो भी पुराना recording है सब I'll send you. And I'll send you the test schedule also. Which week what test. So just to little clarify ना. You'll wait for 1 or 2 minutes. श्लोक का doubt ले लेता हूँ. Then we can talk. ठीक है? हाँ श्लोक बोलो ना.
Sir, last week you said that in inertial frame,
Range. Yeah.
there is Newton's laws are applicable. Sir,
Yeah. Not applicable. My mistake. Not applicable था. Yeah, that was a mistake.
yes, sir, that's my only doubt.
Yeah, it was a mistake. I was telling not, but I wrote R. Yeah. Chal.
Okay, thank you, sir.
Yeah. अरे युक्ति बोलो क्लास में क्या चल रहा है? You're in which class? Spectrum.
हाँ?
You're in which class?
11.
नहीं क्लासेस कौन सा क्लासेस में? फिजिक्स वाला, नारायणा, स्पेक्ट्रम,
हाँ, फिजिक्स वाला.
फिजिक्स वाला रहे. ठीक, क्या चल रहा है भाई पे अभी?
सर अभी पहला बेसिक मैथ्स तो खत्म हो गया और उसके बाद मोशन इन 1D खत्म हो गया और मोशन इन 2D भी खत्म हो
वेक्टर्स भी हो गया,
गया. वेक्टर्स हो गया.
कैलकुलस भी हो गया.
हाँ, काफी पहले स्टार्ट हो गया था. दिसंबर कुछ तो नवंबर दिसंबर से स्टार्ट किया था.
ओह, बीच में 10th एग्जाम्स के लिए गिव अ ब्रेक.
हाँ, बीच में हाँ ब्रेक दिया. उसके बाद अप्रैल से वापस.
कुछ याद था 10th एग्जाम्स के बाद वापस आने को? कुछ याद आया?
हाँ सर, रिवाइज करना पड़ा था बट उन्होंने फिर एनीवेज आगे थोड़ा बहुत रिवाइज करके आगे से स्टार्ट किया. तो
ठीक है. आई थिंक जो भी मैं पढ़ा रहा हूँ ये तो आपको रफली आइडिया तो है.
हाँ,
प्रॉब्लम से थोड़ा, आई होप यू आर गेटिंग समथिंग न्यू टू लर्न, राइट?
मतलब यहाँ पे तो काफी कुछ नया मिल रहा है. मतलब हमारे कोचिंग में इतना ज्यादा नहीं हुआ.
चलो ठीक है. अभी देखो 3 चीज है. वन थिंग यू कैन सी, राइट, हर बार हम पीछे जा रहे हैं. यू सॉ ना इवन टुडे क्लास कितना बार पीछे गया था. सो फर्स्ट थिंग आई वुड से, मेन थिंग बेसिक मैथ्स ना, गो थ्रू दिस होल थिंग वंस. आई विल सेंड यू द नोट्स टुडे. व्हेन आई से गो थ्रू होल थिंग कैसा करना है, मीनिंग सीधा क्वेश्चन, जस्ट पहले सब थ्योरी है ना, पढ़ लो, समझ में आ गया, गो अहेड. देन देयर वाज अ क्वेश्चन, राइट? टेक अ पेपर, ट्राई टू सॉल्व. 4-5 मिनट टाइम स्पेंड करो. आ गया तो अच्छा है, नहीं आया देन सॉल्यूशन देखो. यू डिडंट अंडरस्टैंड, आई विल सेंड यू द रिकॉर्डिंग्स आल्सो. तो जाके रिकॉर्डिंग देख लो. रिकॉर्डिंग देखने बाद भी समझ में नहीं आया, नेक्स्ट क्लास स्टे बैक एंड देन टेल मी, सर बेसिक्स मैथ्स वेक्टर्स में पेज 6 में मुझे समझ में नहीं आया. देन यू कैन डिस्कस, वी कैन सी व्हाट यू डिडंट गेट. डोंट वॉच द रिकॉर्डिंग्स फ्रॉम द स्टार्टिंग, इट्स अ वेस्ट ऑफ टाइम. बिकॉज देखो, नो मैटर वॉट एवर इज द क्वेश्चन, राइट, आई एम श्योर 70-80% तो आ ही जाएगा. So why to waste time watching, na? Wherever you're stuck, then go watch that particular recording for that particular part and come back.
Yeah.
Right? So I think this next 1 week, na, spend time on basic maths and vectors. मतलब ये सिर्फ ये अकेला we did almost 185 to 190 pages. So again, don't try to sit and do everything in one day. It will become too much. Maybe every day 20-25 pages. बस, if you do that much little ना, because आपका classes का work भी करना है ना. You can't ignore that. So don't try to sit one day and do 100 pages. Like you will get overwhelmed. एक minute, why is this thing still recording?